Hello students, today we're looking at the differences between and versus or in the context of probability. So, to put it pretty simply, if we hear the word and in probability, we got to think multiplication. Whereas if we hear the word or in probability, we have to think addition. So what would this look like? Well, let's say I roll a die, a normal six-sided die. What's the probability of a 6 or an even number? There's that word, or. So basically, I need to find the probability of a 6 and plus the probability of the other even numbers. So there's a 1 in 6 chance I get a 6, and there's two other even numbers on a die, 2 and 4. So 1/6 plus 2/6 gives me 3/6, which simplifies to a half. On the other hand, a question like this is saying, I have 4 counters with 1, 2, 3, and 4 in them. 3 counters are randomly selected with replacement. What's the probability of picking all 4s? Essentially, this is asking us to find the odds of getting a 4 and a 4 and another 4. So since I'm hearing the word and, I have to think multiplication. So the probability of 3 4s, well, that's the odds of 1 4, 1 over 4, multiplied by probability of a 4, 1 over 4, multiplied by the probability of another 4, 1 over 4, giving me an answer of 1 out of 64. This one's a little different. 2 lucky dips are drawn without replacement. So remember, that means I'm not putting them back in the box. Anyway, 2 lucky dips are drawn without replacement from a box containing 3 winning and 7 losing packs. What is my probability of winning twice? As you can see here, it's essentially asking us to find the odds of winning again and again. So winning once and winning a second time. So my odds of 1 win are 3 out of 10. Yeah, 3 winning, 7 losing. My odds of winning the second time, though, have changed because it's without replacement. There's only 2 winning tickets left because I got one of them over here. So now there's only 2 winning tickets left out of 9 tickets in total. So 3/10 times 2 9ths would give me 1/15. We can also apply this kind of stuff to cards. So let's say I grab a card from its deck of cards. What are my odds it's a diamond or a club? So I'm hearing the word or, so I have to think plus. So I'd go, okay, what's the probability of a diamond plus the probability of a club? 13 out of 52, 13 out of 52, add them together, simplify my fraction, 1/2. A 2 or a heart, well, that would be a bit different. Well, basically, what's the probability of hearts? That's 13 out of 52. Then 2 of clubs, so I've got all the hearts, there's 3 other 2s in the deck, the 2 of clubs, the 2 of diamonds, and the 2 of spades. So the probability of hearts is 13 out of 52. I add the 3 other 2s, gives me 16 out of 52, which would simplify to 4 out of 13. We could also get something like this, a jack or a 4. How many jacks are in the deck? 4 out of 52. How many 4s are in the deck? 4 out of 52. 8 out of 52 is what I would add them to, because I'm hearing that word or, which simplifies to 2 out of 13. Finally, we can get trickier ones, a 2 and a heart. But guys, just remember, and means times. So the probability of a 2 is 4 out of 52. The probability of a heart is 13 out of 52. What's 4 out of 52 times 13 out of 52? Well, 1 out of 52. Oh, and hang on a minute. In a deck of cards, how many of them are both hearts and 2? Well, there's only 1 2 of hearts in a deck, so that's why this answer should look familiar. Clearly, a 2 and a heart, well, there's only 1 2 of hearts in the deck, so that's why my answer is 1 out of 52. Anyway, students, I hope this has been helpful in clarifying the difference between these terms. Key takeaways: if we hear the word and in probability, think multiplication. If we hear the word or in probability, you've got to think addition.